And we also have a method called synthetic division. It's a shortcut performing long division with certain polynomials. You can use it only when a polynomial is divided by a first-degree polynomial of this form, a 1x minus something. The coefficient of the x has to be a 1. We can only use synthetic division when we're dividing by an x minus a number. It's the only time we can use it. Some things common mistakes that happen with synthetic division that happen, the one we have you avoid. The divisor must be in the form x minus c. Now, of course, that can be a plus c, and that's minus a negative. You have to include zeros as placeholders, just like we did with the polynomial division. And you avoid accidentally using the incorrect value of c. And that comes here with our x minus c. We have to make sure we use the correct value when it's x minus c. And here is an example, and follow these steps. Now, if this form is x minus c here, then my c equals a positive 3. And that's what we're going to use as the divisor, a positive 3. And we're not bothering to write the x's here. We're only writing the coefficients. And we have to make sure we don't skip anything. So 3, 2, 1, 0, we've got everything. 4, leave a little room, negative 15, 11, negative 10. And we draw a line here. The first thing we do is bring the 4 down. It's a 4. Now we multiply 3 times 4, and we get 12. And we add negative 15 and 12, we'll get a negative 3. Now I multiply again. 3 times negative 3, I will get a negative 9. Adding, I'll get 2. And 3 times 2 is 6. Adding, I will get a negative 4. Now, this negative 4 is my remainder. This is my polynomial, my quotient. And since this started with an x cubed, this becomes an x squared. So my quotient here is 4x squared minus 3x plus 2, and the remainder is negative 4. Again, it's x minus c, so in this case c equals 2. 2 goes on the outside. Here's a 2x cubed minus 3x squared. 0x would be the next term, so 0x minus 4. You bring down the first number. This is 2. 2 times 2 is 4, and we add, we get 1. 2 times 1 is 2. We add here, we get 2. 2 times 2 is 4, and when we add, we get 0. That's my remainder. So my quotient here, this was an x cubed, so it becomes 2x squared plus 1x plus 2, and my remainder is 0. Remember, it's x minus c. So in this case, c equals negative 2, because x minus a negative 2 would be x plus 2. So we have a negative 2. And it's a case where we have to fill in the places. So we have 1 x to the 5th, 0x to the 4th, 0x cubed, 0x squared, 0 x's, and 32. We follow the same steps. Bring down the first coefficient is 1. Take 1 times negative 2 is negative 2. Adding, I'll get negative 2. Negative 2 times negative 2 will be 4. Adding 4. Negative 2 times 4 is negative 8. Adding, I will get negative 8. Negative 2 times negative 2 is 16. Adding, I'll get 16. And negative 2 times 16 will be negative 32. And I'll have a remainder of 0. So my quotient for this problem, this was an x to the 5th, so this goes down 1 at 1 degree. X to the 4th minus 2x cubed plus 4x squared minus 8x plus 16. And my remainder was 0. Practicing this division for a reason. If a polynomial p of x is divided by x minus c, then the remainder equals p of c. So if I fill the number in for c, I would get the same thing as if I divided. I'm sure that would be true. So let's look. We kind of have a proof of it here. We have a polynomial and any complex number c. There's a unique polynomial, the quotient, and the remainder r, such that original polynomial, this is my divisor, times the quotient plus the remainder. Well, let's fill in and let x equal c. So p of c then, filling in a c, c minus c equals the quotient plus the remainder. Well, c minus c is 0, so p of c would equal, this will be gone, would equal the remainder. That's the proof that that really works. Let's look at another proof that it works. Let's find it. So here we have a polynomial, and we're going to find p of 4. So that means negative 3 times 4 to the 4th plus 15 times 4 cubed minus 50 times 4 plus 25. So negative 3 times 256 plus 15 times 64 minus 200 plus 25, or negative 768 plus 960 minus 200 plus 25. You'll find out that that equals 17. So that's my p of 4. Now let's use the remainder theorem. It says if I divide by x minus 4, I will also get 17. Let's check. Well, dividing by x minus 4, let's use synthetic division. Since it's an x minus 4, negative 3, 15, we'll have 0x squared minus 50 plus 25. Using my synthetic division steps, bring down the negative 3. 4 times negative 3 will be negative 12. Add, I'll get 3. 4 times 3 is 12. Add, I'll get 12. 4 times 12 is 48. Add, I'll get negative 2. And 4 times negative 2 is negative 8. And 25 minus 8 is 17. There's my p to the 4. So this actually really does work.